so whenever you are ready. Okay, so let me actually just...
So it's intro, name, school, and then what we did today.
Yeah.
Got it.
Let me just make sure your audio is good. Okay, go ahead.
Okay. My name is Ryan Redd, and we are at Myrtle Grove Middle School in Wilmington, North Carolina. Today's lesson was it was a building upon a previous lesson where we introduced systems of equations and the idea that the point of intersection can mean several things in the context of a problem. Today we didn't really work with any real-world problems because we needed to I needed them to practice manipulating equations and then to graph the equations in order to find the point of intersection.
Good. Let's see here. So the first question is, how does this lesson connect to and build on students' prior skills and knowledge? What was taught before the lesson and what will come after it?
Okay. So this lesson builds upon several different standards, several different lessons that we have completed. So it definitely ties into the previous lesson about systems of equations and what they are and what does their point of intersection mean, and looking at them graphically. It also builds upon their understanding of AE7, which is manipulating equations, solving for equations with variables on both sides, as well as the expressions and equations from 6th and 7th grade, where they build upon one-step equations to two-step, to now we're looking at multiple-step equations. From here, we will go into real-world problems of systems of equations where the equations are not set up in y-intercept form, so they will have to manipulate the equations from standard form to y-intercept form in order to either graph them or solve using the substitution method.
Talk about the standards or cluster targeted in the lesson. What did you do to make the lesson reflect the full intent of that standard or cluster?
So the standard focus for this lesson was 8 EE 8. I need to look at my standards. I'm sorry.
Yeah, no worries. The question, or do you want to go right into it?
Yeah, if you don't mind asking the question again.
So talk about the standards or cluster targeted in the lesson. What did you do to make the lesson reflect the full intent of that standard or cluster?
So the overarching domain is 8EEC8, which is analyze and solve pairs of simultaneous linear equations. But I focused on the standard 8EEC8A, which is understanding that that solutions to a system of two linear equations correspond to the intersection on their graph. So this is different than the previous day where we looked at real-world situations. Now we're just going back to the equations and to their graph.
Which of the core action indicators do you think this lesson best exemplified?
Okay, so I'm going to grab this.
Okay.
Yeah. So this lesson exemplifies core action 1 and 2. All of core action 1 because I completely focused on the standard and the graphing piece of it, and it relates to their prior knowledge, going back to just working with functions and equations. And it does target an aspect of rigor, the conceptual understanding about the structure of equations and moving the equations around, although we did touch on some procedural skill and fluency because they just needed to manipulate the equations. I think core action 2 was a big part of this lesson. They had ample time to work on their problems, grade level problems, but I think the biggest piece for me would have been core action 2 indicator D, checking for informally students' understanding, but also making adjustments. So I realized quickly that there were probably 4 students who weren't quite sure how to change the equations to make them in slope-intercept form. So I did spend a lot of time working with those kids or those students one-on-one. Probably the best thing would have been to have paired them up with maybe a stronger student, so to move them from their particular partner that they weren't really talking with as much as I would have hoped, but maybe to have partnered them up with a stronger student who could have helped them out.
Moving on to the shifts. So discuss how this lesson illustrates the shifts required by the CCSS.
Focus, come here, trigger. Okay. This lesson focuses on the shifts, definitely focused. We spent a lot of time today just working on the graphing and finding the solutions of the equations through the graphs. Also, coherence, it totally builds on all of their work that they have done in middle school about manipulating equations, as well as their work with functions and graphing linear equations. With rigor, this lesson was a tad bit difficult to pin down because they weren't applying anything, although that is called for in a later standard in this domain. But they still needed their conceptual understanding of the structure of equations in order to manipulate it to become y equals mx plus b, to graph it.
How did you teach the content of this lesson prior to the CCSS? What is the same and what is different?
So prior to the Common Core, what I would have done would probably be stand up in front of the class. We all worked through the questions together, even though a bit of the class would have been fine with moving on to manipulating the equations themselves. I would have stopped and everybody would have worked on problem one together. We would have graphed it and come to the solution, and then moved on to the next question. And then maybe after 3 or 4, I probably would have let them go on their own. But really now focusing on this idea of kids working together to come to a solution, working together to strengthen their understanding of a concept based off of each other's understanding. That has really been a big focus of mine this year. And today with this lesson, that was the point of the partner activity. Would be like if I got stuck on a problem, then Ashlyn would be there to help me to move on when we realized we didn't have the same solutions, and then we could talk about our solutions, or our methods to get to the solution.
How did the students handle this lesson? Did they understand the mathematics of the lesson?
So I think probably 80% of the students understood the math of the lesson. They, as I said before, there were several students who struggled with not the graphing piece, but the manipulating the equations to make them look like linear models, and that was difficult for them. So then, therefore, they were not able to reach the objective of the lesson, which was to graph and define the solution of a pair of linear equations.
Explain how you differentiated in the lesson. Did all students have opportunities to work on grade level content?
So all students had the opportunity to work on the content. My differentiation here was putting them with someone that, number one, they felt comfortable talking to, but then also someone that they could really rely on to help them when they got stuck. However, that differentiation didn't work out quite as planned because they just wanted to have help from me versus help from their partner.
Which behaviors from Core Action 3 did the students best exemplify in this lesson?
So I need to take a second and grab these.
Possible.
Yep, certainly.
Okay. So which behaviors from Core Action 3 did the students best exemplify in this lesson?
So I think the majority of students in the lesson exemplified Core Action 3 indicator B and C and D. I think that they were able to persevere even though the problems were challenging and the problems were difficult. We didn't have much instruction on how to change the equations to look like a linear model where they could graph it. So a lot of them didn't even require my help. They were able to work with each other and use Core Action D, where they were able to talk about each other's thinking to help them understand how to go about solving the problem. I think that Core Action C is something that we're working on, where they are still explaining their thinking without my prompting, even though I do prompt them and ask them to explain their thinking. So they're really good at that. And I think that's it.
Let's see here. Let me skip the submitted student work. So reflecting on the lesson, what worked particularly well and what might you do differently?
So I think the activity was a great activity to have them partnering up, working together, doing the same problem and then coming together after the problem was finished to work on the solution together. I think next time I would do this differently. I would definitely rearrange the grouping, as well as give them explicit instructions not to move on to the next problem until their partner is ready to go. I saw some kids who went through the entire sheet without, they would check their partner's solutions every now and then, but they did not wait to move on to the next problem to make sure that they both had the same exact solution.
Were there any surprises or unexpected student behaviors or reactions?
Actually, I was very surprised at how well they were able to handle the content of the lesson. I thought, without having any prior instruction, to manipulating the equations to make it look like a linear model, they were able to do it and figure it out on their own. It showed me that they had a real good conceptual understanding of equations and how they work, and also what sort of knowledge they needed to have linear, or to be able to graph linear functions. I was surprised at some students who weren't able to do it, and that was a shocker. So I will make sure that I work with them to hone in on those skills.
That's it.
Okay, yay! Sorry, I tried to make it fast. We're not